Hi guys, so I wanted to make a quick little video here that summarizes some aspects of chemical naming, or what we call nomenclature, and to tell you the different kinds of problems you're likely to see on our quiz that we'll have. So the first kind of naming problem that you're likely to see is just what we call simple ionic. And remember, to know how you have an ionic compound, that means you're grabbing a metal and a nonmetal from the periodic table, something from the left and something from the right. A simple ionic basically just has one kind of metal and one kind of nonmetal. Now, there might be different numbers of those atoms in a formula unit, but it's only one metal and one nonmetal. And those are pretty straightforward. They can get a little bit more complicated if we have what we call multivalent metals. So valent is just sort of a fancy word for charge. So some of those metals might have more than one possibility for the charge that they could have. So I'm just going to kind of run through a little organizational way of thinking about the 7 that I do need you to know. So that's kind of adding on like a little extra flavor to the metal piece. There are a lot of polyatomic anions. So there's a couple polyatomic cations that we know of, but most of the polyatomic species that we know are anionic. So we're going to have polyatomic ions. And as I said, most of them are going to be negatively charged. So we can take a regular old metal that we might know, and then we start mixing these polyatomic ions. So I'm going to go through sort of an organizational strategy for some of the more complicated polyatomic ions. Then we have hydrates. And you may or may not see a hydrate. Hydrate's pretty straightforward. You basically are having water molecules that are hooked onto an ionic compound. And you'll see those in names. For example, if we talk about magnesium sulfate, you might see that it has 2 waters as part of it. So when you see it as part of the chemical formula, you'll see a dot and then a certain number of H2O molecules. When you see it in the chemical name, what you'll see is you'll see the word hydrate, and then in front of the word hydrate, you'll see the number of water molecules. So for example, this is magnesium sulfate dihydrate. So not a lot of flavors or permutations you can have with those problems, because it really is just almost like it's one little extra piece with it. So just know how to use that. You may or may not see a hydrated compound in either the forward or reverse direction on your quiz. Next piece is sort of talking about binary covalent compounds. And just like we had simple ionic compounds, basically grabs one element as a metal and one element as a nonmetal. Our binary covalent compounds just grab one element as a nonmetal and then one other element as a nonmetal. So it's 2 nonmetals. It's not to say that there's only 2 atoms that are in your molecule or your compound, but it's only 2 kinds. But you're going to see 2 nonmetals when we have covalent compounds. So we went through some examples in class for how you might name those. And so you're going to see those Greek prefixes again sort of coming into play there with that mono and di and so forth, all the way up to 10. So you need to know those Greek prefixes. Think of your shapes for those: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. That'll get you through 1 through 10. The last piece, and it's going to be part of this video, but something to think about, is acids. So acids are kind of tricky because it kind of builds on having multiple pieces, if you will. So you need to know how to properly name the compound, and then you need to know how to tweak that to name it as the acid. So it's a little bit more involved. And so this is going to be something that I think is one of those challenge skills. So I'm going to offer this as extra credit on your quiz. So if you feel like you've got all this other stuff down, you're fine with it, take a stab at trying to work through knowing your acids. We will get to a point in the course where you do have to know them, but I'm okay if it's something that we're going to sort of put off till later. Okay, so now we're going to walk through, I'm going to highlight here what the video will focus on. These multivalent metals, so thinking about how we want to think about those. Talking about some of the polyatomic ions, particularly the ones that are bound with oxygen. So we'll talk about different classes there. And then I'll talk a bit about acids. Okay, so let's move on and talk about So let's go through how we would think about these multivalent metals. So just some numbers to kind of get in your head so you can sort of remember some of this. There's 7 that I'm going to ask you to know. And of those 7, there's 5 that we want to think about that have sort of common names. So as we sort of go through, I'm going to make a little list here. I'm going to categorize these in a way that maybe it can help sort of put them together. So we're going to talk, and I'm going to make a little table here. There's going to be charges that these have. We're going to write down, again, what the ions are. We're going to write what the root is for those ions, and then that'll help us think about the common names. So the first set, there's really only 2 that we're going to have as part of this set, are things that come as +1 or +2 flavors. So the first one to think about is we're going to have copper as a +1 and copper as a +2. And again, whether you write +2 or 2+, that's really semantics. That doesn't matter. The root for this, it's not copper. It's going to be CuPr. And that little Cu reminds us of the Latin origins of this, which is why copper has the atomic symbol Cu. But when we use and name things with common names, we're going to use 2 different suffixes. So I'm going to write these up top here. We're going to have an OUS suffix. This is for the lower charge number. And then we're going to have an IC that is going to be for the higher number. Okay, so when we put all of this together, we're going to have cuprous for the +1 charge, and then cupric. So those are the common names that we'd see for those metals with those charges. There's another set that's a little bit weird to think about for a +1 and our +2 charge, and it's going to be a mercury series. This one's a little bit odd, okay? But mercury comes as the +1 flavor when there's 2 mercuries that we have here for a total charge of +2. Now, what that kind of really means is that each mercury itself is +1, but we have 2 of them, so they're together and they're +2. I know it's a little bit weird. That one's kind of a weird one, but then we have mercury straight up as a +2 charge. So when we think about mercury, there's going to be, that is that mercure, so without the Y, that is going to be our root. So it's mercurous and mercuric. So those are going to be how we handle that. So those are our 2 things that come as a +1 and a +2 flavor. We've got copper and mercury. All right, so let's talk about the +2 and +3 flavors. Okay, there's 3 things that come as the +2 and +3 flavors. The first one we're going to talk about is iron. So iron is 2+ and 3+, right? The root is going to be Fer, and that again reminds us why iron has the symbol Fe. So this is going to be ferrous and ferric. Another one that's +2 and +3 is chromium. So chromium 2+, chromium 3+. The root is going to be chrome. And so we're going to have chromous and chromic. All right. Last one that we have here is actually one that we don't have a common name that you need to know, and that's our cobalt. So cobalt is cobalt 2+ and 3+. So nothing to think about here with a root or, again, our suffix. All right, the last group are 2 that I want you to know that come as +2 and +4 flavors. So +2 and +4. This is going to be tin and lead. So let's start with tin. Tin is going to be Sn, so it's Sn2+ and Sn4+. The root is stan, and this helps us understand why the chemical symbol for tin is SN. So we're going to have stannous and stannic. And the last one is lead. This is another one that we don't have common names that I need you to know. So lead is going to be 2+ and 4+. No roots that we need to know. So again, those are the 7 that I need you to know that are multivalent metals, but only 5 of them have common names that you need to know that are based on using the OUS or IC suffixes on the roots. So next I want to move on to our polyatomic ions that have other nonmetals with them, specifically halogens or nitrogen, carbon, sulfur, or phosphorus. So those are going to be kind of a unique group. There's lots of other polyatomic ions that we've talked about, but these ones sort of fall into a class because there's some patterns and they're easy to get confused. So 2 different classes that we're going to have. The first is going to be what we call the oxyhalide series. So these are going to follow the pattern. There's going to be an oxygen, a halogen, and then some number of those halogens. Okay, so that N is going to be equal somewhere between 1 and 4. So X can be equal to chlorine, bromine, or iodine. And reminding us of what those prefixes are, we're going to have chlor, brome, or iodo. So what I'm going to show you is how this pattern works for the first halogen in the series, but then you'll see that there's not just 4 possibilities, there's actually 12, because the same pattern is going to apply for the bromine series and then the iodine series. Okay, so let's go through this. I'm going to highlight too that these are all -1 ions. So that's a common feature that we have here. There's all going to be -1 no matter how many halogens we have. So let's walk through with our oxygen chlorine series. So we're going to have OCl, OCl2, OCl3, and then OCl4. So they're all -1 anions, but we need to think about how we name them. So all of these are going to have the same root in the middle. And so when we're talking about this oxygen chlorine series, it's going to be chlor. And what's going to happen is the ones that are in the middle are going to have the suffixes ite and ate. So this is going to be ite and ate. And those are done. Those guys in the middle are done. So we've got OCl2 minus is chlorite, and then OCl3 minus is chlorate. Now how we're going to distinguish these is we're going to keep the guy that's 1 less or 1 more chlorine atom still going to be ites and ates, but now we have to put a prefix in the beginning to sort of distinguish these. If you are less than, you can think about being hypo. Like if you're hypoglycemic, you have low blood sugar. Now, normally we think of the opposite of that as being hyper, but we're just going to use the per part of it. So this is going to be per to indicate that we're 1 more than. But you can remember the word hyper, like hyperactive or hyperglycemic, having excess sugar or excess energy. So in this case, the series going from 1 through 4 chlorines is going to be hypochlorite, chlorite, chlorate, and perchlorate. All right, so remember this actually applies to the bromine and iodine series as well. So if this was a bromine atom that was all through here, then this would be brome as the prefix. So it would be hypobromite, bromite, bromate, and perbromate. And then if it was iodine that was here, this is an iodo prefix, so it's hypoiodite, iodite, iodate, and periodate. I know this can get really, really crazy, but that's the series that we have, the oxygen halide series. Another series that has lots of permutations, this time where we're going to be changing the number of oxygen atoms, is what we're going to call these oxygen polyatomics. These are going to follow the pattern where we're going to have X, O, and N. And X in this case is going to be equal to nitrogen, copper, sulfur, and phosphorus. We're going to just have those four elements that we're going to kind of consider here. And then what we're going to consider is that they can have different numbers of oxygens, and it's not going to be every possible. It's not going to be, all of them having 1 through 4 possibilities for the number of oxygen. So that's one of the categorizing pieces that we're going to have here. So I'm going to make a little table here to help us sort of summarize this. We've got nitrogen, copper, sulfur, and phosphorus. So again, we're going to have a nitrogen series, carbon, sulfur, and phosphorus series. Some of them might only have one player in them, but we'll see how this works. So why I've got this organized the way I do is we're going to have all of the nitrogen series are going to be -1 charged. The carbon and the sulfur series are all going to be -2 charge. And the phosphorus series is going to be -3 charge. So let's run through what these are, and then we'll kind of talk about how we name them. And so for the nitrogen series, it's going to be 2 and 3 oxygen atoms. So we're going to have NO2- and NO3-. I'm going to give myself a little bit of room here so we can write the names for each of these underneath. So what we're going to have is we're going to have 2 suffixes that we use to sort of name these, and they're going to be ite and ate. So again, suffixes here, we're going to have ite and then ate. And like we saw for going through the oxygen halogen series, if there are 2 possibilities, the ate is going to be for the one with the higher number of oxygen atoms. So in this case, we're going to have the first one be nitrite, and the second one is going to be nitrate. Okay, so I hope you see that pattern. The thing that you do need to remember is that all of the nitrogen oxygen ones are -1, and that the 2 flavors that we have are 2 and then 3 oxygen atoms. We actually only have one that we're going to see here for our carbon oxygen series, and that's going to be CO3, 2-. If there's only one, we're going to name it with the 8, so this is carbonate. So our next little piece is to deal with sulfur and phosphorus. So these are different in that all of the sulfur ones are going to be -2, all the phosphorus ones are going to be -3, but what's the same is the number of oxygen atoms we're going to see, which is either 3 or 4. So we can have SO3, 2-, SO4, 2-, and then we can have PO3, 3-, PO4, 3-. Okay, so those are the possible options we can have for those. Now going ahead and naming them, this would be sulfite and sulfate, and then this would be phosphite and phosphate. All right, one little last piece to add in here is any of these species that have at least a -2 charge, we could bundle it with one H+, one hydrogen with a positive charge, and still have a polyatomic anion. And so we need to think about how to name those. So if you can add hydrogen, there's 2 ways that you can indicate that you've done that. You can say hydrogen, the word hydrogen, or you can use the word bi. So let me go through some examples here. We could have HCO3- because we've added an H+, then that is going to now just be a -1 anion. And so this would be bicarbonate. Okay, we could then also have I'm just going to talk about these, HCO3-. that would be bisulfite. We could have bisulfate. And we also can have these as hydrogen sulfite or hydrogen sulfate. Now, when we get to the phosphorus series, because that has a -3 charge, we could actually add 1 or 2 hydrogens. So in that case, we actually have to have a Greek prefix in front of it. So for example, if we had HPO3 2-, this would be monohydrogen phosphite. If we had H2PO3 single-, this would be dihydrogen phosphite. So we'll see more application of this as we see how these get played into their use as acids. So we're going to see that in our next video. So our last little piece here is on naming acids. And because we really haven't talked yet about acids in class, I'm going to sort of have this be as a challenge or sort of an extra credit bonus skill. We will need to learn how to name acids by later in the course, but if it's something that you're just feeling like you want to put off for right now, totally fine. To help us understand how acids are named, I want to just talk a little bit about what acids are. We can think about acids as any species that has an H+ cation with it, okay? And we can have any number of those that are going to be with some type of an anion, okay? And so we have to think about how many hydrogen atoms we're going to have to balance out the number of negative charges on the anion. So looking at some of the species that we have here, depending on what the charge is, might determine how many hydrogen atoms we might have with it. So for example, we could have these two would each be HNO2 and HNO3. They would be what we call monoprotic acids, having only one proton, remembering that this species is called a proton. That's not super important for learning how we name these, but it is important for us to sort of just understand what an acid is. So naming acids, pretty much any species that we have here can be bundled with a corresponding number of protons, and then we would name the associated acid. So what we need to do is we need to figure out whether there's an ITE or an OUS ending on the acid. So if there is an ITE ending on the anion that we have with the acid, and so whatever this polyatomic anion is, so things like these chlorite or hypochlorite, phosphite, sulfite, nitrite, those are going to become OUS acids. And we'll go through a few examples here in a second. If it is an ATE suffix, that's going to become an ic acid. And as a little silly way to help you remember this, remember we talked about ate. If you ate something, you're going to feel full, something like that, to help you remember that the ate goes with the larger charge on our ions and so forth. If you want to remember, okay, now I ate something icky, that helps you remember that the ate suffix becomes an ic acid. All right, so the other piece that we have to kind of highlight here is some of our roots become a little bit different, particularly the sulfur and the phosphorus roots. So that sulf root becomes sulfur, and that phos root becomes phosphor. All right, so let's go through and we'll just kind of grab a few randomly here to sort of try. So let's take OCl3. If we put a hydrogen with that, we'd have HOCl. That came from hypochlorite. So we would take the hypochlorite, and what we do is that ITE is going to go away, and it becomes OUS, and then we add the word acid at the end. So that would be hypochlorous acid. Kind of running through without writing them down, this would be chlorous acid, so we don't have the hypo there. This would be chloric acid, and this would be perchloric acid. Hopefully you see the pattern that we have there. Let's just run through these because this is a set number of examples here. Okay, and again, we're not considering the ones that already have the hydrogen with them in terms of the naming piece. We're looking at the guy that basically had no hydrogens with it. This guy was nitrite, so HNO2 becomes nitrous acid. HNO3 is nitric acid. Carbon, as carbonate, now becomes carbonic acid. This is sulfurous acid, sulfuric acid, phosphorus acid, and phosphoric acid. So we've actually run through most of the acid names to think about. Most of the acids, again, we're going to encounter are going to be these anions. We also have ones that are formed what we call the hydrogen halide series. So that's where we're going to have this A group is going to be one of the halogens. So that's going to be HF, which is hydrofluoric acid, HCl, hydrochloric acid, hydrobromic acid, then hydroiodic acid. So that's what we call the hydrogen halogen series. And the only other acid that we've sort of talked about that's what we call a binary acid. So it is a gas that we, or an acid that we make by bubbling a gas in water. So HCN. So this is one that we haven't really talked about. So you might see that as either cyanic acid or hydrocyanic acid. All right, so that's really it for acids. Again, if acids kind of get you tripped up a little bit, don't worry about it right now. That's something that we can deal with later. You are going to get to a point where you have to know how to name acids. But if you're focusing on these other parts right now, don't worry too much about acids.